நான் இப்போ எங்கே பார்க்குறது கொஸ்டின்ஸ் வந்து இல்லை கொஸ்டின்ஸ்லாம் இதில் தான் வரும். Hello everybody, welcome to the live session for the Material and Energy Balances course. So if you have any queries, I'll be happy to address. So a few of you had submitted some queries earlier, so if you're here, please do inform me. I'll try to address them. If not, please post your questions now and I'll try to answer them as best as I can. Again, overall, can I see who's watching?
Sir, forum la indha question kettirundala adha explain pannalam sir.
So one of the questions which was posted was whether the the topics on the chemostat and other bioreactors, is that relevant for chemical engineers? So it technically is, because the principles which we use there are very similar to what you would see in a CSTR. So in a continuous stir tank reactor, you have the same principles. So the only difference here is, instead of using a simple rate equation, so usually for a chemical reaction the rate would be zero order, first order, second order, and so on. So instead of using that kind of a rate equation, you would be using the Monod's model or other models which describe these or Michaelis-Menten model which describe the reaction kinetics. So that is the difference. However, the concept of the balance equations and all those things, they are still the same. There is no difference there. So it is important that you do learn these fundamentals. They can actually be helpful. And obviously, if you are going to work on biochemical engineering or biotechnology eventually, which is highly likely if you pursue higher studies, it is important for you to understand these principles as well. So if you were to look at most of the top universities, you would see that a significant amount of research related in the chemical engineering departments has a lot of biology component to it. So it is important to understand the biological aspects and how to use these principles for chemical engineering systems. So for that reason, I would suggest you do learn these principles. However, they are probably not very crucial right away, but the principles are the same and it is important to learn them anyways. If you have any queries, please post them here. We will try to answer them. So the questions you have posted in the forum, we have tried to address most of these questions. We have answered them. So if you still have require clarity on some of those doubts we had shared, so please feel free to ask them as well. We will try to address those issues as well. Very few simple questions which we have already answered. So because any questions in forum, we do send submit answers right away. So that's the problem. So that's why, and might not be the same people sitting here. I was worried about the time as well. Because எல்லாருக்கும் காலேஜ் இருக்கிற டைம் இது, அதுதான் யோசிச்சேன். இல்லைன்னா
அதனாலதான் சார் நேற்று வாங்க சொன்னார். ஏன்னா ஸ்டூடெண்ட்
ஈவினிங் வச்சிருந்துருக்கலாம். நான் நினைக்கல. ஈவினிங் 5 o'clock ஈவினிங் might be better. So, one of the common concerns many of you had during, from what I saw in your the forum, was how the answers were not exactly accurate as what I have given to you, or like you got an answer which you believe was more accurate, and so on. So that's usually because of rounding off errors. So when you are performing calculations, what I would recommend is do not round off in every step. So use the actual values you get for the intermediary steps. When you finally write down, make sure you write it down in a way that corresponds to the significant figures. And if you cannot do that, then other option is for you to write it to the reasonable accuracy instead of just writing every digit possible. So try to use computational tools, especially for your whatever you're doing for your assignments. So try to solve them, and do not round off every step. So when you try to do that, there is going to be so much of carryover effect that the final answers won't come into the range which I'm looking at. So I usually give a range for the numerical answers for the assignments, and it may not actually fit in this numerical range if you round off every single time. And the ranges I give are usually quite small, because I'm trying to find if you are able to arrive at the same answer. But I do plan to increase these ranges soon, so that it will be a little easier for you to. I don't want you to be penalized if you have gotten an answer which is reasonably close. So I do expect to do that, and in the final exam, the ranges will definitely take into account such errors. So I request you to do this. Basically, don't round off in every step, and finally, your rounding off can be done only for the last answer you write down, and individual steps you keep sticking to whatever values you have. Okay, so that will minimize some of the errors. So some of you had also asked whether I will be performing any things on. Uh, Sorry, there is a question here being posted. Earlier, your courses were easy to answer on mobile phones. Now you have banned it. Why are not able to? Yet you promised to do something, still not yet. Uh, okay, I have not actually banned anything, so there might be some issues with the NPTEL website. Let me check with the technical staff here. Excuse me, madam. ஏதோ ஒரு ஸ்டூடெண்ட்டை ஏதோ மொபைல் ஃபோன்ஸில் ஆக்சஸ் பண்ண முடியலங்கிற மாதிரி போட்டிருக்காங்க. ஸோ வாட் இஸ் த ப்ராப்ளம்? என்னது, எனக்கு எனக்கு இது பத்தி ஒன்றுமே தெரியாது.
லிங்க் எதுனா ப்ராப்ளம் இப்போ நானும் பார்த்து திரும்ப அதில்
So the technical staff are saying that it is possible to open on mobile phones, and you should be able to access these things. I'm not sure why you are not able to. So please do try again. If you have any issues, please feel free to send an email to us, to the technical team. We will try to address it. We do want you to use mobile devices, and most of the videos which we make and the questions which we make are compatible for these platforms. And we do make sure that it is accessible for people who do not have access to a PC directly. So in case there are issues, please contact us. We will try to address them immediately. I'm not sure what you specifically mean by saying we have promised to do something. I'm not sure what exactly was communicated to us. So please contact the NPTEL technical team and they'll be able to resolve this issue. Okay, so assignments do not appear on mobile, is it? So I'm not sure why, because I have not changed anything. So assignments, we are actually giving questions with an option to fill the answers in the mobile. So I'll check with the technical team. I'll contact with them and try to resolve it right away, so that students are not affected because of this. We do want to make sure that mobile and other platforms are accessible. Okay, so as I was about to say, there was another query on the forum where people had actually said that asked whether I'll be performing humidification and dehumidification kind of questions, and perform material balances for topics which are more closely related to chemical engineering than to biotechnology. So this course itself is tailored towards material energy balances with for biological systems and bioprocess engineering and biotechnology. So I'll perform different types of examples which will be applicable to biological systems. So, humidification and dehumidification specifically, I might not be performing example problems. However, the principles which we cover here are exactly the same for those types of problems as well. So, you would still be able to use the general balance equations, and you would be able to apply the concepts which we have talked about. So, except that I would not be talking about things like vapor pressure or Raoult's law and Antoine's equation and so on. So those are not directly relevant for biotechnology students in many cases. So I have not focused on discussing them in detail. So however, you feel free to refer to the textbooks which I had suggested. Those are standard textbooks in chemical engineering courses, and you would be able to you will be able to pick up some of the concepts, and you would be able to apply the same principles which we have covered, and that will definitely address your concerns. So Anand, as I have already told you, Anand, I have received your complaint, and we will talk to the technical team and try to get this resolved, because I'm not sure as to why this has happened, because I have not made any changes from my side. Uh, the technical team should be able to figure it out, and I wasn't aware of this issue. So I will talk to the technical team as soon as I end this live session, and I'll try to get it resolved definitely before the next assignment goes live. And we'll also make sure that the other assignments are also accessible through mobile. We will see if this has been a problem for many people, and in case it has been a problem for many people in other places as well, so we will try to figure out some viable alternatives. So many of you had asked about uh, like the assignment solutions. So we have been trying to upload step-by-step solutions for the problems which I have given out. So please go through them. They are quite self-explanatory. I have tried to write down every step possible so that you would be able to follow exactly as to what needs to be done. In case you are not able to follow that, you have some queries, please write to us. We will try to address this. And if there are any typographical errors or if there is some issues because of that, please let us know. However, we have tried to make sure that the solutions are given in a very clear step-by-step fashion. So that should help you. What I would recommend is go through these assignment solutions in addition to whatever videos you're watching. So that will really help you learn and familiarize yourself with the process. So this course itself, the concepts are very simple. The topics which we cover, the fundamental concepts we cover are simple, but it's mostly about practice. We need to practice these problems multiple times. Only then we will be able to solve these problems effectively. So these problems are not too difficult if we follow the procedure step by step. However, usually what happens is students tend to skip steps. We try to solve them quickly because in simple systems it is actually not too easy, difficult. So we would be able to see the answers. We will actually be able to look at the answers and come up with the solutions for very simple single unit systems. But as the systems become more and more complex, it becomes difficult, and we try to do the same thing which we have done for single unit systems without going through the procedures. So that becomes difficult. So please don't do that. So I have prepared the slides, and I've done my solutions for my practice problems and for the assignments in a step by step way, so that you will be familiar with the exact procedure and the exact method which needs to be applied. So that is the most important thing in this course. Make sure that you learn the procedure and protocol and follow it meticulously, and by doing that you will not have any issues. So I had in the early classes itself, and even in our website, we have listed the reference books and textbooks for this course. Please do go through those textbooks. They have a lot of example problems and many exercise problems. So these exercise problems will really help you fine tune your skills. So please, if you have access to the books, if you can get it from the library or something, please do borrow these books from your library. Try to solve all the problems in the back of the textbook, and try to apply the principles which you have learned. That will really help, because the concepts you learn in this course, material energy balances, will be applied in many of the higher level courses. So if you're talking about bioreaction engineering or chemical reaction engineering, or reactor design, downstream processing, transport phenomena, all these things actually, this concept of balances, input minus output plus generation minus consumption equals accumulation, is a formula and the equation which is consistently used. And it is important that you do continue learning these concepts and try to understand and apply this one simple equation. So as I said, the concepts which you learn in this course are not too difficult, right? So the entire course is built on one equation. It is only that input minus output plus generation minus consumption equals accumulation. That is one equation. And if you know this one equation, you will be able to solve every problem in this course. However, it is difficult when you are trying to apply this equation to different systems. When you have different systems, you need to make sure that it is applied effectively. So you need to make sure you apply the same policy principles and use the same procedure, and that needs to be prepared meticulously. And so please, this comes only through practice. Just by looking at videos, you will not be able to solve these things. So what I would strongly recommend is, even in my own videos, just watch the video once, and then you should actually, when you're rewatching it, you should pause the video with the question. So whatever question I have, so just pause the slide with the question and try to solve it on your own. Try to see whether you are able to get the same answers that I am getting. So now that we are so like 7 6 7 weeks into this lectures, so you already have completed half the course. So material balances is fully completed now. So you should be able to perform these calculations without difficulty. So what I strongly suggest is, uh, even in the older videos, please go back and pause the videos, look at the questions. So the slides have also been shared for you, so you can just take the questions from the slides and try to solve every question on your own, and see whether you are able to get the same answers, and see whether you are able to use the same principles and same procedures. By doing that, you will actually be able to familiarize yourself effectively. Others who are watching, if you have any queries, please do post them. I'll be happy to try and address them effectively. இது என்னன்னு பார்க்கணும் மேடம். அவங்க இவங்ககிட்ட கேளுங்க. அவங்ககிட்ட ஏன் அப்படி வருதுன்னு. ஏன்னா அசைன்மெண்ட்ஸ் மட்டும் பார்க்க முடியலன்னா என்ன பண்ணுவோம்?
தெரியலங்க சார். நாங்கலாம் இப்போ லைவ்ல மொபைல்ல தான் பார்த்துட்டு இருக்கோம்.
இல்லை, பட் அசைன்மெண்ட் மட்டும் வரலன்னு
அது
சொல்றாங்க.
கால் பண்ணி சொல்லியிருக்கேன்
அது
சார்.
என்னன்னு
பார்த்து
தெரியல.
செக் பண்ணுங்க சார்.
So, what else about this course? Uh, Yeah, so Anand, there is a Miss Lakshmi Priya who's trying to address your question. So she's been asking you to use this desktop site, or switch to desktop mode on your mobile. So even if you have the mobile phone, you can still access it. Just make sure you access it in the desktop mode. Then you will be able to access it instead of the mobile version of the website. Try to access the desktop version of the website. Hopefully that will resolve the problem. In case you still have a problem, the problem persists, please get in touch with us again. So can you just try that and see if it is working? So, as I was saying, the textbooks which we have prescribed, the Felder Rousseau, Himmelblau, uh, Pauline Doran, and Satterback, these are four different textbooks, authors of the four different textbooks. And these books are some of the standard books used all over the world, and they have a lot of problems which can be worked out. And please do refer to these books and see whether you can solve these problems. um, like practice as many problems as possible, because the fundamentals you use here and learn here will really help in many of the higher level courses. uh, and it can, so it is the course which we are teaching is a very important basic, which helps in building so many different courses. So please do try to apply these principles and try to use them appropriately. Another question that was asked in the forum was about the molar and mass balances. So, where people had asked concerns about why I was using molar balances for reactive processes when moles are not being conserved. So what you need to understand is the total moles of a system will not be conserved in a reactive process. So that was the example which I was giving. So you have H2 plus half O2 giving H2O, that is 1.5 moles, 1 mole of hydrogen and half mole of oxygen reacting to form 1 mole of water. So 1.5 moles of reactants forms 1 mole of product. So that means that the total number of moles is not conserved. However, if you're talking about the number of moles of water itself, that will be conserved. Number of moles of hydrogen, that will be conserved. So individual components, molar balances are valid. Only total molar balance is not valid. So you cannot use total molar balance. You could use individual component mole balances. So that's why I have written mole balances. And when you write mole balances, you can also use the stoichiometric coefficients directly for the generation and consumption terms. However, if you were to write mass balances, you would have to use the stoichiometric coefficient and also the molecular weight of these components, and then get the total number of total mass which is generated or consumed, and use that as the generation or consumption terms, which could be a little trickier and tedious. So that's why I perform molar balances for reactive process. But please note that it is done only for individual components. Total molar balance should not be written for reactive processes. That is not concerned. However, total mass balance and individual component mass balances are written. And similarly, the number of atoms of each of the in each of the compound will also be conserved. So number of hydrogen atoms and number of oxygen atoms will be conserved in the reaction which I just mentioned, where hydrogen and oxygen reacts to form water. So those kinds of conservation still exist. Okay, so that's why we write molar balances. So using them correctly will make sure our calculations are simpler. Um, So now that we have started the energy balances, I hope you are able to follow the fundamental principles. So the objectives and procedures for energy balances are the same, and I have tried to strictly follow the procedures step by step and without making much changes. So I hope you would also follow these procedures meticulously. As you see, the reason I try to follow the same steps every time and for perform multiple problems with the same concepts again and again is to make sure that the procedure becomes second nature to you. It is important that you start doing the same thing in the same fashion every single time rather than doing it in different approaches. So trying to do different approaches is not a good idea because you in some case sometimes you might get the right answer, but the problem is you will not be able to replicate it. So you only can get it right every single time if you follow the same procedure every single time. And this is more about discipline and being rigorous. So this course is all about rigor. It's not about just a high IQ. So intelligence definitely helps, but hard work and rigor is a lot more important in this course rather than brilliance. So please do follow the procedure and make sure you follow it every step. And doing it that way will ensure that the problems you do are simple. And definitely, if you are to register for the semester exam, the final exam, you would find the questions to be a lot simpler if you were to follow the same procedure. Yeah. However, if you try to use different steps every single time, you will find it to be much harder. Yes,
ஏதாவது பேசுங்க சார், பேசாம இருக்கும். சப்ஜெக்ட் வைஸ் எதனா கூட எக்ஸ்பிளைன்
yeah.
பண்ணுங்க சார்.
What to do?
இல்ல அது 10 மேல இருந்தே வரலைங்க சார். என்ன எக்ஸாம் டிப்ஸ் எதனா கூட பேசாம இருக்கக்கூடாது. மேம் கேட்பாங்க சார். நீங்க
Okay.
ஃபோரம்ல இருக்கிற கொஸ்டின் கூட ரிப்ளை பண்ணுங்க
Forum.
சார்.
Sorry, that's what I've been doing. So I've been trying to answer the forum questions.
பேசாம இருக்கக்கூடாது. எக்ஸாம் டிப்ஸ் என்ன எதனா ஒன்று ஒரு கான்செப்டை எக்ஸ்பிளைன் பண்ணுங்க. ஜேர்னல் ஃபைல் கூட ஓப்பன் பண்ணி தான்
It's already okay. So, okay, some of the major concepts which you have covered in this course are about the material balances till now. So we will be talking about energy balances in the next few weeks, and we have started energy balances. And as we are looking at energy balances, the concepts are simple. The fundamentals are actually the same. So you try to use the same principles, and we try to use the same equations. However, that it becomes a lot trickier because with energy balances, we need to understand what type of a system it is, and we need to try and understand how to use this particular system, and we need to look at using the system for using different equations for the appropriate system. So as I had mentioned earlier, you can also rewatch the videos. So you would be using the enthalpy when you perform energy balances for open systems. So the equation would be Q minus Ws equals delta H plus delta Ek plus delta Ep. So where delta H is the change in enthalpy. Whereas if you have a closed system with a constant volume process, then you would use internal energy instead of enthalpy. So the reason is when you actually have work, so the work actually has two components. So work can have shaft work and flow work. Flow work is the PDV work. So work associated with change in volume or change in position. So this PDV work uh, is present in all open systems, even when there is no change in volume, because you have the components coming in and leaving. So this flow work, which is the PDV work, needs to be accounted for. And when we account for this PDV work, the equation which has the delta U then has delta U plus PDV and delta U minus PDV, which is here delta H, and including the PDV, it becomes an enthalpy. Similarly, in cases where it is a constant pressure process, instead of having a constant volume closed process, so the closed systems would also have a PDV work, which would be because of the change in volume. So the moving of the boundary will have a PDV work. And this PDV work being present is result in an enthalpy term instead of an internal energy term. That's why for open systems and closed systems at constant pressure, you would use change in enthalpy in your general energy balance equation, and for closed systems at constant volume, you will be using change in internal energy for the general energy balance. So it is important that you understand why this is being done. Okay. And other than the energy balance, general energy balance equation, there is also the mechanical energy balances which we recently started to discuss. So you would have seen the videos. So the mechanical energy balance equation is for systems where the change in temperature is not significant. However, there is going to be major changes with respect to the velocity or height or pressure difference and so on. So that's why you use mechanical energy balances separately. So these equations also have important applications. So when you're trying to design pumps and turbines and so on, the mechanical energy balances are crucial. So it is important to use them appropriately. So whenever you perform energy balances, the equations would have to be simplified correctly. So you have the, for example, for an open system, you would have Q dot minus Ws dot equals delta H dot plus delta Ek dot plus delta Ep dot. So here your Q dot would be zero if there is no heat exchange. Q is the heat term, right? So as we have said, the energy can be transferred from between the system and the surroundings in two forms. One is heat, other is work. So Q is the heat. So if you are going to have difference in temperature between the systems, there can actually be heat exchange. So that is Q. So when there is no heat being transferred, then it is Q would be zero. So for an adiabatic process, Q would be zero. When there are no moving parts in your system, then W will be zero. WS specifically, just shaft work will be zero. Whereas if you have a system where there is no change in velocity or no major change in velocity, then there is no change in kinetic energy as well. So that can be considered to be zero as well. So if there is no change in position, then you consider change in potential energy to be zero. So simplifying the system will really make your calculations easier. So even when there are probably some changes to kinetic and potential energies, in many cases we can ignore them unless it is very large. So usually these values are much smaller compared to a change in enthalpy for chemical processes. In case of mechanical processes, however, these cannot be ignored. So there, your change in kinetic energy and change in potential energy have significant role compared to your enthalpy changes. So it is important to use them correctly. So, 11 வரைக்குமா?
எதனா எக்ஸாம்பிள் கூட எக்ஸ்பிளைன் பண்ணலாமா சார்? அமைதியா இருக்கக்கூடாது.
Yeah, that's fine. But see,
நீங்க
the thing is,
ஜெனரலா
it's the
எதனா
same
டயகிராம்
concept.
எக்ஸ்பிளைன் பண்ற மாதிரி.
It's the same concept which I'll be explaining again.
அப்படி இல்லையா சார்? ஆ சார்.
Okay, so I'll try and explain the energy balances which I just discussed. So what we have is energy balance for an open system is given as Q dot minus Ws dot equals delta H dot plus delta E K dot plus delta EP dot. So as I was saying, for an adiabatic system where there is no heat exchange, Q dot will be equal to zero. And if you have no moving parts, so shaft work will be equal to zero. So this is for an adiabatic process, and this is for no moving parts. And your delta ek dot would be equal to zero when there is no change in velocity, and delta ep dot will be equal to zero for no change in position, no change in velocity and no change in position. Yeah, so using this equation and these concepts, you can simplify this equation and you will be solving for delta H dot and delta E K. Okay, so what you need to understand is in many of the chemical processes, the equation simplifies for an open system simplifies to Q dot equals delta H dot. So this is because usually in open systems there is also change in transfer of energy in the form of heat. So that is calculated using this. So you would have to calculate delta H dot, and depending on what type of a process it is, you will be using calculating delta H dot differently. Change in enthalpy will be, so you can calculate delta H. So as I said, or as I have said earlier, you can calculate only change in enthalpy. You cannot calculate the enthalpy of a particular point. So you calculate change in enthalpy. So when there is for different processes, so this can be calculated when there is delta T, change in temperature, change in pressure, change in phase, or there is mixing or solutions, right? So these are the only conditions where you can actually have the change in enthalpy calculated. When you have change in temperature for this process, you would have integral Cp dt. So this is for delta H cap. Okay. So from temperature, initial temperature to final temperature, or inlet temperature to outlet temperature, you can actually perform this integration. And Cp is usually a polynomial in terms of temperature. So using this, you will be able to calculate the temperature process. In case of change in pressure for ideal gases, it will be zero. For ideal gases, the delta H equals zero. Okay, H cap equals zero. For solids and liquids, it is not zero. However, it is delta H cap is given as V cap delta. For solids and liquids, it's given as delta H cap equals V cap delta P. So this V cap delta P is usually very small. That's because V cap is very small. V cap is nothing but inverse of density, right? So when you have inverse of density, it would be very small for solids and liquids, because density of solids and liquids is significantly high. So V cap would be very small. Because of this, this V cap delta P term would also be very small. So in many cases, you can actually approximate it to be zero, and you would still not get any errors. So that is why it is okay to do this approximation. In case of phase change, then you would have to look up tables where you can get standard heat of phase change. So the phase change could be because of heat vaporization or condensation and so on. So we'll be talking about phase change in the next few lectures. So the next week we will be talking about phase change operations, right? So at that time we'll talk about this. And mixing and solution we'll discuss in the subsequent week. So again, so only for these types of processes we can calculate enthalpy changes. So that's why we need to perform something called hypothetical paths. So as I had mentioned in my lectures, the enthalpy is actually a state function. It's a point function. It's not a path function, right? So if it is a path function, we wouldn't be able to do this. So we need to have from one point to another. So this would be the actual path. Let's say it is a liquid at T1 degree Celsius and uh, P1 atmosphere pressure. So from here, if it goes to vapor at T2 degree Celsius and P2 atmospheric pressure. So here you have all three things changing, right? You have the phase, temperature, and pressure changing. So for this process, we would not be able to calculate the change in enthalpy because multiple things are changing. So instead, you would build a hypothetical path where you have only one thing changing. Let's say there is only change in temperature to get to liquid at T boiling point of that component, TBP degree Celsius and P1 atmosphere. And from here, you might have to move it to liquid T boiling point and to 1 atmosphere, right? Because that is where you would usually have the phase change temperature. So here this is again delta P, only change in pressure. So from here you go to phase change happens. So here you would have vapor at boiling point degree Celsius and 1 atmosphere, and so here only phase change is happening. And then from boiling point you can go to T2. So you will form vapor at T2 degrees Celsius and 1 atmosphere. And from where you go to the final step. So in this step you again have only delta T, and the last step you have only delta P. So now what will happen is for a process where there are multiple things changing, you have now built hypothetical paths where each step has only one of the things changing. So first step you have only temperature changing, second step you have only pressure changing, third step you have only phase changing, fourth step you have only temperature changing, and fifth step you have only pressure changing. So doing this you will be able to calculate the change in enthalpy for individual steps. So this is the simple concept. Okay. And another concept which I would like to in material balances, another concept which I would like to explain is the recycle. So recycle, as I said, the system is in steady state even when there is recycle. So this material is circulating without being accumulating. So that is important to understand. So as I was explaining in the lecture for recycle, what happens is initially, let's say you have 100 kilograms of a substance coming in and 100 kilograms of the same thing leaving. So here you are not having any recycle, right? So and the system does not have any accumulation. 100 coming, 100 leaving. There's no accumulation. However, you can have accumulation if you were to take out some of it and give it back here. So if this out of the 100 which is coming in here, coming out here, so if I were to take out 50 here and only 50 is being recovered here, then what will happen is you have an accumulation now because 50 is being building up. But what actually would happen is this 50 now mixes with 100 to form 150, which is entering the system, and this would also be 150 kilograms. Okay, so once this is 150 kilograms, if I continue taking only 50 kilograms back into the system, then this will automatically become 100 kilograms. So therefore, you would have a state, a steady state system without any issues. So that is what we have been talking about when you're saying in recycle there is no accumulation. You can actually have material circulating without accumulation. Um, it is important to understand this principle of recycle because that will really help in getting clarity that that's why we are actually able to get accumulation to be zero. In the last week of this course, we will actually talk about unsteady state systems. So for 11 weeks, we'll only talk about steady state systems. So uh, So, for until we'll be talking about only steady state systems. So, what will happen is once we have steady state systems, the accumulation always goes to zero. So, eventually, when we talk about unsteady state processes, that is when we will talk about accumulation. So accumulation is actually a factor which changes with respect to time. So it would not be an algebraic equation like what we have been looking at. So it will be a differential form. So we'll have to use integration and calculus to actually solve this. In the last week of the lecture, we'll talk about this. So why we don't discuss unsteady state extensively is most of these processes are actually in steady state. If you were to take a chemical or a biochemical industry, unsteady state process happens only at the time of startup and shutdown. So normal operation is always at steady state. So that is why it is important. Sorry, uh, battling a little bit of cold. So unsteady state is happening only during the startup and shutdown. So in a chemical or biochemical industry, the startup and shutdown is maybe 5 to 10 days a year. The rest of the operations are always at steady state. So it is important to understand steady state operations fully. But because unsteady state is also possible, especially in biological systems, there can always be unsteady state. So it is important to learn a little bit about them as well. So we will talk about unsteady state processes in the last week of the class. So I hope you are able to learn something in this live session. And but anyways, if you have any queries, feel free to contact us and post on the forum. We try to answer all the questions which are posted on the forum. Uh, Myself and my TAs have been actively looking at the forum and we have been trying to answer every question. If you have any of the concerns, please do keep in touch and please email us as well. And if you have any technical difficulties in watching the videos or any attempting the assignments, please let us know. So, thank you. So,